Section P.5 is about algebraic expressions. I think I have told you about algebraic expressions when we have studied P2. I told you what we did for numbers in section P2, we will do it later for algebraic expressions. What we mean by algebraic expressions, how to add them, how to multiply them, how to divide them, how to do the algebraic operations. We will see that today, inshallah, except for division. For the division, we will use it or study it in section, in chapter 3. I don't remember which section exactly. Also today, we will see, especially at the end, how to use the special product formulas. First of all, I believe that all of you know what we mean by a variable. What we mean by a variable, it is just a letter that used to represent any quantity, any real number. The algebraic expression is when you have a combination of variables, powers, addition, subtraction, operation, any algebraic operation. So if you have variables such as x, y, or z, and some real numbers, and they are combined together by addition, subtraction, multiplication, division, powers, root, and so on, then we have what is called algebraic expression. When you have a combination of variables and numbers, this is what is called algebraic expression. All of these are algebraic expressions. Now, there are some specific type of algebraic expressions. Let's talk about a term, what we mean by a term. Like, this is the formal definition, by the way, for the term. What is the term? It is the product of real number and one or more variables raised to a power. Like here, we have a variable, which is x, raised to a power, which is 2, multiplied by a real number, which is 2. So this is a term. This is a term. This is a term. We have 3 terms here. Similarly, when you have square root of y, this is a term. If you add these 2 terms, you have a real number, a variable here raised to the power. Here you have 3 multiplied by y to the power 0. There is a variable here, but we didn't write y to the power 0. It is 1. So what is it? What we mean by a term? A real number multiplied by a variable or more. And this is also one term. If you have 3x squared y to the power 5, this is also one term. You have a real number. It could be square root of 3, by the way, no problem. Square root of 3 multiplied by y squared multiplied by y to the power 5. All of these 3 quantities, we have square root of 3x squared y, all of them are one term. Now, the real number that we are talking about here, like this one, or this one here, or this one, we call it, in fact, here -3, and here 2. We call it coefficient. What is the coefficient? It is the real number that is multiplied by the variable. Okay. For an instance here, we have, this is a term, this is a term, this is a term. Now, what is the coefficient of the first term? 2. Of the second? 1. Of the third? Negative. Don't forget the negative. Like here, the coefficient of x here is -3. Excellent. Now we have a special type of terms, which called monomial. What we mean by monomial? Monomial, this prefix, ya shabab, I think you have an idea about it in English. Mono, it means single, one. Bi or die, it means 2. Tri, 3, and so on. You can find, of course, many of these. They are a combination of Latin and Greek language. Tetra, hexa, octa, and so on, until they found mega, giga, tera. So what is monomial? What do we mean by monomial? It is a term. Shortly, you can think about it like a term, but it is a special term. There is something special about it. It is like this. It has this form. A real number, which is a, multiplied by a variable to the power k. What is k? This is the main part here. K is a non-negative integer. What does that mean? 0, 1, 2, 3, and so on. So the power here couldn't be any power. No, it must be non-negative integer to have a monomial like this. For instance, this is monomial, negative 3 to the power x, or negative 3 times x. It is a monomial. You have here a real number, which is negative 3, multiplied by a variable, which is x, raised to the power, which is 1. Now, these two are not monomials. Why this one, the first one, is not monomial? The power here, it is x to the power a half. So it is not a non-negative integer. This one is not monomial because we have two terms. In the monomial, according to the definition, we have it is just when you have this expression, this form. Great. Now, when we have the sum of two monomials, it is called binomial. If we have sum of three monomials, we call it trinomials. And when we have more than that, we will call it in general polynomial. Also, poly, it means multi in English, multi, many, several. So in general, shabab, it is polynomial. These are just special cases or special names. So in general, they are called polynomial. This is what we mean by polynomial. When we have, of course, a real number multiplied by a variable to the power non-negative integer. What is important in this definition is this part, that the powers here are non-negative integers, 0, 1, 2, 3, and so on. Yes?
So you simply add the powers, and if it's
not the powers. No, we're not adding the powers. We're adding the terms to have polynomial. This is term, this is term, this is monomial, monomial. Each one here is monomial. Let's call them shortly term. But of course, when we say terms when we talk about polynomials, by term we mean monomials. The power must be non-negative. Yes. Yes, please.
Could A be a rational number?
Any real number here. Look, it is mentioned here that these coefficients, they are called, by the way, these are called coefficients, and these coefficients are real numbers. Any real number. Okay. Now, let me mention this, Shabab. You know, for example, when we have 4x to the power 5 minus 3x squared plus 1 plus x plus whatever. So let's say minus a half x plus square root of 2. This is polynomial. Now, what are these constants that we are talking about? They are 4, negative 3, negative half, and square root of 2. Now, what about if I want to have, for example, a polynomial with 100 terms? With a few terms, it is not difficult. If you want to say ax squared plus bx plus c, this is easy. We have 3 letters, a, b, c. But what about if I have 100 terms? So it is not practical to use the letters a, b, c. What we use this notation in mathematics, and this is very effective. Now, you use one letter, which is A, but you can make with this index, instead of A, I will write A1, and just I mean the coefficient of x squared. Plus, you can use to make it related to the power, call it A2, and this one call it A1, and this one call it A0. The same idea. This is a real number, this is a real number, this is a real number. For example, here it is square root of 2, here it is negative half, and here, of course, it is negative 3, and so on. So when you have something like this, this is called a Shabab subscript, and you can read it AN. It is formally A subscript N, but we shortly read it as A sub N, or just more shortly AN. Now, AN, the coefficient, these are called the coefficients. This coefficient, which is the coefficient of the largest value here, this is the largest power, ya Shabab. The power here, A0, x to the power 0, x to the power 1, 2, 3, 4, 5, n minus 1, until you have n. So this is the largest one. If it is not 0, then this n is called the degree. So this is a polynomial of degree n. And the monomials, of course, they are called terms. So what we mean by terms of the polynomial, we mean each one of these monomials. The leading coefficient, an, the coefficient of the largest with the largest value, or the coefficient of the largest power, is called the leading coefficient. We will see the importance of this in chapter 3, inshallah, when we study polynomials. Chapter 3 mainly is about polynomials. Here in this table, we have examples about some polynomials. What is the type of this polynomial? What are the terms, and what is the degree? Look at the first one. Here we have a polynomial. It is a polynomial. How many terms we have? 3. So it is called trinomial. What are the terms? 2x squared, -3, and 4. What is the degree?
2.
Look at the highest power, and it is the degree, of course, among the non-negative integers. For the second one, it is binomial. Binomial, we have 2 terms. We call it binomial. What is the degree?
8.
What are the coefficients? 1 and 5. The terms are x to the power 8 and 5 to the power. The coefficient of x to the power 8 is 1. The coefficient of x is 5. The third one, we have here polynomial of degree 3. The degree is 3. The highest power is 3. And how many terms? 4 terms. 5x plus 1, 2 terms. And it is called binomial. This one, it is 1 term only, monomial. The degree is what? 5. The degree of this one is 1. What is the degree of the last one? 0. In a constant, it is called the constant term. It is in fact 6x times 0, which is 6 times 1, which is 6. So we shortly write it 6. Excellent. Now this is, ya shabab, if we have one variable. What about if we have more than one variable? Like this. This is still a term. Is it a term or not a term? It is a term. If I have a plus here, it is not a term. It will be 2 terms. But this is 1 term. It is all about multiplying factors. Now, this is the coefficient. Now the power. What is the power of this term?
13.
It is the sum of the powers of the variables. So it is 12. Now, if you have a polynomial with several variables, by the way, this is not used heavily in this textbook, but just to have an idea about it. What will be the degree of the polynomial with several variables? This is a polynomial with x and y variables. So it is, in fact, will be the power or the degree of the highest term. So here, the degree, the power of this term, the degree of this term is 7. The degree of this is 6. The degree of this is what?
8.
So the degree of this polynomial is what?
8.
It is 8. Which one of the following is a polynomial of degree 2? What do you think? Which one of the following is a polynomial of degree 2? Let's start, ya shabab, one by one. Is A polynomial of degree 2?
No. It's not polynomial.
Why it is not a polynomial?
X is
What? You mean this term?
X in the middle.
So 2 over x, it is just 2 multiplied by 1 over x. It is 2 times x to the power -1. Yes. So this is not, we said that in the polynomial, the powers are what? Non-negative integers. So this is negative integer. So because of this, it is not. So this is not a polynomial. The second one, for the same reason, it is not a polynomial. Okay, for this one, why?
Because x to the power -3.
We said that the polynomial, it is a sum of monomials. So where is the monomial here? The monomial, it has this shape. So here it is, in fact, polynomial of degree 1 divided by polynomial of degree 3. So it is a quotient of 2 polynomials, but it is not a polynomial. Okay, and we will see that later with details. Of course, you need here the degree of the denominator of the numerator to be greater than or equals to have polynomial. Here at the end, the degree will not be, the power will not be non-negative integer. Of course, we should have it always in this way. A real number multiplied by a variable to the power that is non-negative integer. And what about d? Why d is not a polynomial? Because of this term. So this is x to the power a half. Now, for the last one, it looks like the last option is the correct one. Is it a polynomial? What about this, ya shabab? We have here square root of 2.
Not,
It is the coefficient, not the variable. Great. So no problem. We could have this. This could be real number, no problem. X is a variable. K is a non-negative integer. Now, what about the degree? It looks like it is of degree 3, not of degree 2.
We can make it to the
So, how to make sure about that? We need to expand this. We need to find what is this to expand it. This is what we will see. We will come back to this question, Shabab, after studying how to find this product, how to find this multiplication. So we will come back to this question, inshallah, after studying the special product formulas. Do you know what are like terms? What are like terms? Like terms are terms with the same variable raised to the same power, like this. These two terms are like, but these two are unlike. Why?
it's not raised to the same power.
Yes, this is the same variable, the same power, but these are the same variable, but not the same. You cannot, of course, add and subtract unlike terms. This is why we talked about them here. So how to add and subtract polynomials?
Should be the same power and the same variable.
They should be like terms, just shortly like that. So to add and subtract polynomials, we will use the properties of real. What is this? P2. And the idea is to combine like terms using the distributive property, P2 again. So this is the distributive property. Look at this easy example. 5x to the power 7 multiply or plus 3x to the power 7. It is just what? 5 reals plus 3 reals, it is 8. In fact, at the back stage, we are using the distributive property, but we don't usually write it, okay, in these easy examples, but in general, it is there. So how to add, ya shabab, and subtract polynomials? So easy. So this is a polynomial plus another polynomial. What we will do, we will combine like terms. So it will be x3, x to the power 3 plus x to the power 3. It will be what? 2. So it is not bad to group these like terms. So you can group them. What we mean by that? X cubed with x cubed, x squared with x squared. So the like terms, put them together because the addition is commutative. So you can rearrange the terms. But of course, you can skip this step. You can go directly to this. X squared plus x squared, it is 2x squared. Negative 6 plus 5, negative 1. 2 plus negative 7, it is negative 5. And 4 plus 0, it is 4. If you have subtraction, you have to be careful. When you have subtraction, you need to first distribute. Use the distributive property here. The distributive property, use it, and then add the like terms. How to multiply algebraic expressions in general? In a special case, how to multiply the polynomials. طبعا يا شباب, now the algebraic expressions, they are more general than the polynomials. Polynomials are just special case. To multiply algebraic expression, you will use what? The distributive property several times, repeatedly. Like here, for example, you will multiply A by these two terms, then B by these two terms. Usually we don't do this step, but it is there. Usually we go directly, ya shabab. A times C, A times D, B times C, B times D. Or we do it this way. Now, if you notice here, if you want to remember or recall, if you want to give it a name, this method that we are doing here, it is called FOIL, or shortly FOIL. FOIL is about what? Multiplying the first term by the first term. So F, it is for first terms. Then the outer here by the outer here. So it is what? Outer terms. Then the inner terms. B times C, they are the inner terms. So this is for inner terms. And then last term by last term. Of course, for algebraic expressions, you need to use, of course, the distributive property and the laws of exponents, like this. How to multiply this? Let's start from there, over there. What is this equals to? We will multiply 2x by 3x. What you will get? 6x squared. You are right. So this is what we are going to do. The first term by the first term. Then you will multiply 2x by -5. Don't forget to multiply also positive times negative. It will be what? 2x times -5, negative 10x. Then you will multiply 1 by these two terms. And you know, multiplying 1 by any quantity, you will give you the same. So just rewrite it there. Here we are. Are we done?
No,
What we need to do?
we have to subtract 10x and
What is that called? It has a name. Combine like terms. So we have here two terms that they are like terms. Excellent. Now what we will do, ya shabab, what we are doing now is called simplifying or multiplying or expanding. So this is P5. The job that we did now, it is P5. What we will do in P6, section P6, we will do the opposite. We will go how to go from here to here. What is that called? Factoring. So this will be the subject of section B6.
what this called again?
Simplifying, multiplying, expanding, you can call it whatever, but it is not factoring. Factoring, when you have this trinomial and you write it like this is called factoring. Now, how to find this product, ya shabab? Again, the same idea. You will multiply 2x by this trinomial. We have a binomial multiplied by trinomial. So it will be 2x. You can do it, ya shabab, immediately, but to be more sure, you can do it this way. 2x multiplied by these three terms, and then 3 by this one, using the distributive property. And then apply the distributive property again. So you will multiply 2x by x to the power 2, and you don't forget, when you multiply two expressions with the same power, you will just add the exponents. Combine the like terms. We are using the laws of exponents, and then we combine the like terms. Don't forget about the negative signs. Now, what I want you to do, ya shabab, is to find each of the following products. And I don't want the final answer. I want the detailed solution. How you obtain the final answer. So please just apply what you have learned so far. Apply the FOIL, first by first, outer by outer, and then inner by inner, then last by last. Yeah, right, please. If you can, why not? During that, ya shabab, I will, yes, all of them, and show me how you obtain the result. Don't just write the final answer. Do the process, do the multiplication. Because it looks like you need to know from where these are coming. I will pause the recording and take the attention. So what we will do in the first one, we will just apply the FOIL. I know that you know the final answer, but of course you need also to know from where to obtain that. Don't depend on your memory. Sometimes you forget things. So mathematics, it is not about memorizing formulas. It is about how to obtain these formulas. So now we'll multiply a by a. It will be what? A squared, positive by negative, it will be negative ab, plus positive by positive ba, minus b, positive by negative is negative b squared. Now this is what? This is a squared minus b squared. Why? Because here the multiplication is commutative, so this is ab plus ab. So it is the negative y plus y, so they will be cancelled. So these will be cancelled. And this is why this is equals to a squared minus b squared. Be careful, shabab, about the mistake that your colleagues has done. This is not equal, shabab, to a minus b all squared. Be careful. We cannot distribute the power over the sum and the difference. So this is not. Be careful. So now, ya shabab, you don't need to do this. If I ask you next time, what is a plus b times a minus b? What is this? A squared minus b Squared. And this is the formula that we have. This is the first formula from the special product formulas. The product of the sum of two terms with the difference of the same terms equals to a squared minus b squared. The first term squared minus the b squared, the second term squared. Later, we will call this, later in P6, we will call this difference of squares. Okay, let's come back here. What is a plus b all squared? I noticed that many of you, they write it a squared plus 2ab plus b squared. This is correct. This is correct. And unfortunately, I noticed that some of you, they said that it is equals to a squared plus b squared. Is this correct?
No.
This is not correct. Be careful. So here, my target was to know, ya shabab, how to obtain this, from where it comes. In fact, what is x squared? X times x. So in fact, this is a plus b times a plus b. And this will be what? By using the FOIL, it will be a squared plus ab plus ba plus b squared. ab, it is the same as ba. The multiplication is commutative. So it will be a squared plus 2, because both of them are positive. And here we are. So what will happen if it was negative? What do you think? If it is negative here, this will be negative, this will be negative, but negative by negative, it will be positive. So it just will be negative. So this one will be a squared minus 2ab plus b squared.
How can I do it?
The same. I did it here above. Do the same. It will be a minus b times a minus b. Which will be the same as look here, what is in red above. And you can continue using the FOIL. But again, ya shabab, if you can use the last formula and you are sure about it, good, why not? Now, how to find this? A plus b all to the power 3. And this we will come back after that to the recitation question that we had. So now how to do that, ya shabab? You know that x cubed is what? X times x times x, which can be written as x times x squared. So now what I will do, I will write this as a plus b times a plus b all squared. I have this from here. I already have it and I already proved it. So it will be what? A plus b times, what is a plus b all squared? It is a squared plus 2ab plus b squared. Now I will do FOIL. I will multiply now. I will use the distributive property. This will be equals to what? You will multiply a by these three terms, then b. So it will be what? A to the power 3 plus 2a squared b plus ab squared. Is that right? We finished multiplying a by all the three terms. Now let's multiply b. So it is positive by positive. It will be plus b a squared plus 2a b squared plus b to the power 3 b cubed. Now if we need to combine the like terms, a cubed, is there any other a cubed? A cubed plus 2a squared b. We have this is a squared b. Where is a squared b? Here it is. It is commutative. So it is the multiplication and of course as well as the addition, they are commutative. So this will be what? 2 plus 1, they are 3. So 3a squared b. Similarly, we have here ab squared and here what? ab squared. So it will be plus 3ab squared plus the last term, which is what? b to the power 3. So we have now this ready formula, shabab. A plus b to the power 3, it is just what? A cubed plus 3a squared b plus 3ab squared plus b cubed. What is that? If you look at it, you will cube the first one and you will cube the last one. Look, you will make it like that. And then this cubed will be squared and then will be to the power 1. And then, of course, b to the power 0. Here it will be b to the power 3, then b to the power 2, then b to the power 0. So here it will get decrease and here it will get increase for the powers. I will show you a method how can you memorize or remember this easily if you want to use it. But before that, let's mention what will happen if it is minus. here. When you have it minus, you will do the same, just it will be minus. If you want to use this one here, just this will be minus and this will be minus. So this will be negative, this will be negative, and when you multiply by the same way, this will be negative and this will be negative. Okay? So this will be negative, this will be negative. If you repeat that, try to check that. Now, all what we need, ya shabab, to use later is just to try to apply this directly. Just, of course, we will not give you A and B. We will give you other quantities other than A and B. We will use what is called the principle of substitution. And this is one of the most important, ya shabab, principles in mathematics. What does it say? It says that we can substitute algebraic expression for any letter in a formula. Of course, if it is valid, if it is defined as a real number. So we can replace here A by any quantity, by any quantity, or by algebraic expression. But before that, let me ask you how to do this, Shabab. You can do this. You can multiply A by what? By these three terms, then B. Who can tell me what will be the result? Do you know?
We will have a to the power 6.
It will be A to the power
6.
3 plus B to the power 3. It will be. It will. This is a mistake here. Oh, thank you. There is a mistake here. It is B. It is a written mistake. There is B here, of course. And this will be a shabab A to the power 3 minus B to the power 3. I will correct this and re-upload the slides. How to do this, how to know this, we will see that inshallah together in section B6. But please do the multiplication. Do what I ask you to do. You will get this at the end. Check that. Now, look here what I'm talking about. How to use formula, for example, this formula. How to use it with this expression, algebraic expression. In fact, if you look, this is something plus something all squared. So in this case, A is what? Is x squared, and B is what? Y cubed. So what you will do to distribute or here distribute the square, it will be x squared all squared, which is A. Then 2 times A times B, so it is the double of the product A and B. And of course, here it is the product, the square of the last term, the second term. You will simplify then. This will be what? X to the power what? 4. Then 2x here, it will be what, ya shabab? To the power 5? It will stay the same because they are not like terms, of course. You cannot multiply them. They still, of course, not the same base. And this, of course, the last one will be y to the power 6. Now, I need someone, ya shabab, to help me to expand the first one here. What this will be?
9x to the power 2.
It is just the same formula. Which formula of these, طبعا يا شباب? These are your tools. These are the tools that you will use to solve problems. So that you can think about them like keys. So these are keys. Each one of them will open one lock, will solve one problem, will open one door. If you are not using the right key with the right door, it will not be opened. It will not be solved. So now, which one you can use here? Number 2. So in fact, if you don't want to apply this formula, what you can do, you can multiply it by itself 2 times, no problem. You still be able to do that, but you will spend more time. So to save your time, apply the formula. A in this case is 3x, A is 3x, and B is what? Is 5. So it will be directly, if you want to go, it will be 9x squared plus 30x plus 25. You can do it directly, or if you want to make sure about your steps, you can do this. Okay? Before going to B, I'd like to ask you which formula we will use for B. Number 5. You will use the wrong key if you use 3. Be careful. So I will come back to that, but let's go to solve the recitation question that I show you at the beginning. Now, please, who can help me to expand this? Yes, let's expand it, ya shabab. Now, what we will have? Now, how to memorize the formula, ya shabab? A plus B all to the power 3.
That was the wrong answer.
It is what? A to the power 3 plus A to the power 2 plus A to the power 1 plus A to the power 0. It will disappear. Then here we will have B to the power 3, B to the power 2, B to the power 1, then it will disappear. And here we have 3, 3. Do you have an idea about Pascal triangle, Shabab? Okay, it is indeed called Al-Karhi triangle. Originally, it is for Abu Bakr al-Karhi. He obtained this idea, but unfortunately, he didn't publish it or write it in a formal way. Pascal here did it and write it in a formal way. If it is about indeed when you have A plus B, or let's take the capital parts, no problem. A plus B all to the power n. So it could be A to the power 2, 3, 4, 0, 1, whatever. If n is 0, what we have? What it will be? 1. A plus B to the power 0 is 1. So it is 1. When n is 1, it will be A plus B. So it will be, let me write it here, A plus B. So it is 1, 1. This is what Pascal and Al-Karhi they did. And if it n is 2, what it will be? A squared plus 2AB plus B squared. So let's focus on the coefficients. It is 1, 1, 1. Is that right? No, we have 2 here. What is the idea? We are adding these, and the boundaries are 1. When it is 3, it will be what? 1, 3, 3, 1. Look, 1, 3, 3, 1. So it is A cubed. We already have it here. Now, when it is 4, when n is 4, what it will be? 1, 4, 6, 4, 1. So how many terms we have? 5 terms. Always it will be 1 more than. So if you want to write it, look, it will be like this. A to the power what? 4, then A to the power 3, A to the power 2, A to the power 1, and then A to the power 0. B to the power 4, B to the power 3, B to the power 2, B to the power 1, and B to the power 0. Then the coefficients will be 4, 6, and 4, and 1. Okay? So let's see how to expand this, Shabab. Let me change the color. Now, how to expand this one? What it will be? It will be 3x. Do it, Shabab, slowly to avoid any mistake. 3x to the power what? 3 plus 3 times 3x to the power 2. I'm applying this formula now. Times what? Times 2. This is B. Plus 3 times A. A is 3x times 2 to the power 2 plus 2 to the power 3. Don't forget the other terms, plus the square root of 2x to the power 2 minus 27x to the power 3. Now, if you look here, it will be what? 27x to the power 3 plus what, ya shabab? 3 to the power 9. 3 to the power 2 is 9. 9 times 3, 27. 27 by 2, it is 54. X to the power 2 plus, here we have 4 times 9, 36. X plus 8 minus or plus square root of 2x squared minus 27x to the power 3. Now, if you notice, this is a polynomial, but this term will be cancelled with this term. So this is why it is not a polynomial of degree 3. It is a polynomial of degree 2. And what is the coefficient of this polynomial? If you want to continue writing this, let me write it here. What is remaining? What is the, if you want to simplify it more, we are done, khalas. We know that it is a polynomial of degree 2, but if you want to combine the like terms, what you will do? From here to here, it will be what? 54 plus the square root of 2 times x squared by the distributive property, plus 36x plus 8. How many terms? If someone asks you here how many terms, we have in fact 3. They are not 4. You need to combine like terms. Okay. Look now at part B here. It is the same, but you will use formula number 5 where you have negative. So the signs will be alternating: positive, negative, positive, negative. Okay. Again, this is A, and this is B, which is 2. Be careful when you do this, and of course, this will be the result at the end. Any question, Shabab, for so far about this? Now, who can tell me immediately what is the answer of this, the final answer?
4x squared minus y.
Excellent. You are the winner. Excellent. Yes. Which formula we will use here, Shabab? The first one. The first one. It is 4x squared minus square root of 5. This is squared and y squared. And of course, this is 4x squared minus y. What about the second one? Which formula we can use, Shabab? Or there is no one we can use? The first one, we can use the first one? What is the principle of substitution? We can use A here. We can, instead of A, use any algebraic expression. And instead of B, we can use any algebraic expression. Indeed, we can use here formula number 1. What is A? This is A. And this is B. We can use it. Okay. Just make sure that it is you are right using it in the right way. So what we can do, we can use A to be x plus 1 and B to be 1. And what we'll get, ya Shabab? We will get this A minus B times A plus B, which will be, of course, A squared minus B. So it will be what? The first one, this one squared minus 1 squared, which is what? This is x plus y all squared minus 1 squared. Now expand this one. What is this? X squared plus y squared. This is a common mistake, ya Shabab. Please be careful. Plus 2xy if you want to say. I prefer to put it in the middle, of course. Don't forget that. Here it is. And here we are. We have this product. You can do it, by the way, Shabab. You can do it term by term. You can multiply x by these 3 terms, then y, then, but it will be long. So this is why, Shabab, mathematics, it saves our time, of course, and our lives as well. Thank you, and see you, inshallah.